What we're going to do today is work our way through the rest of solid principles. We will go through and review them at the end. As a reminder, the goal is not to remember and memorize every single design pattern that we mentioned. The goal is not to realize that there are probably about 100 different terms in this chapter of the book, maybe more so than others, but to look for the patterns and the big ideas. So you should know what each of SOL, I, and D are. We'll come back to those afterwards, but focus on the problem that we're trying to solve. So with that, we're going to talk about the open and close principle, or the O in solid. The open and close principle sounds a little bit complicated, but the idea is relatively simple and a super important one that you will find in object-oriented programming. And the idea here is that classes should be open for extension, but closed for source modification. And so what do we mean by this? Well, oftentimes when we're working through solving a problem, we might be looking at something like a report, and that report might need to come in different formats. Maybe an HTML report, a CSV, or a PDF report, or a JSON output. The idea here is that in our code, we have some class that generates a report, but we might need to simply present it in different ways. And so the question is, how do we write code that allows us to say, well, if I have an HTML report today, tomorrow I can extend that to be a CSV report or a PDF report without having to go through and modify every instance of a report class that might need to call that code. And so what we should look out for are places in our code where we do things like case statements. And the goal that we want to do is to say, if I need to add a report type, how do I make it such that I can add that new type without needing to modify this code? And the open and close principle says that if a class is open for extension, we can insert something like a new type of class that we'll talk about that allows us to add that behavior without modifying the rest of our code. There are a few different kinds of patterns that Ruby gives us and object-oriented programming gives us in general to address this open and close principle. The question is, how do we know what to pass to the class if we don't necessarily know until runtime what type of format the report might be? You might sort of imagine this in a web app, right? And you've probably seen this perhaps in various tools. In the case of a report, there might be a download button and it might say, what format do you want that download to come in, right? CSV, PDF, Excel, whatever it might be. And in certain statically typed languages, you might call this an abstract factory pattern. Ruby provides some nice examples where, because it is really dynamic, we're not going to go through every single line of code in these examples. But instead of doing something like a case statement, we can have the name of a particular class. And Ruby provides methods like constantize, which turns that text string of a class name into an actual callable instance of a class. And this allows us to do something like, say, pass in a report HTML formatter class or whatever it might be as the arguments to a report generator that allow us to look up the class. And so the abstract factory pattern allows us to say that we have a way of dynamically looking up a different kind of class at runtime from what we might need. There are two other related and common patterns that address the open and close principle. And I think in Ruby land and in Rails, these are some of the two most common patterns that you'll see. They are the template method and strategy patterns. They are related, but slightly different. The idea of a template method is that we have a set of steps that are the same, but the implementation of each step is different. So the way to think about this is every type of report will need to do A, B, and C, but how it does A, B, and C would be a little bit different. Like most of our solid patterns, instead of using inheritance and subclassing, we're going to use delegation to compose the steps into a new class that we call, rather than trying to inherit something. So we're not going to have necessarily an HTML report class that inherits from a report or a CSV report class that inherits from a report. We're going to have a HTML formatter class or a CSV formatter class. The related pattern is a strategy pattern. And the strategy pattern is a little bit more flexible, but the idea here is the task that we're trying to do is the same, but there are many possible implementations for that class. So the way that we think about this is the strategy pattern provides a little bit higher level of a consistent interface that does fewer things, but within each class, those implementations might differ a little bit more. And the idea here again is that we're going to compose smaller classes that build up the whole task. So in this model, we have a couple UML diagrams that illustrate the difference here, is that we want to move from an inheritance model to something like composing classes where instead of having one report class that knows about the different types of formats, we might have some kind of a strategy class where we can plug in different kind of strategies. And you've actually probably used this if you've been following through certain chips, or if you remember back to Module 5. Authentication in Rails through the OmniAuth gem is probably the most popular example of a strategy pattern, in that when we want to do authentication, we have a development authentication provider that on our local machine is very insecure. It doesn't do any actual authentication, but it lets us test the workflow. We have test authentication strategies that work in our test environment that, again, essentially stub out the calls. But then we also have, importantly, right, a GitHub strategy. We might have a Google strategy. We might have strategies for every other kind of service that might exist, including more custom ones that implement sort of enterprise single sign-on. But all of these strategies are strategies because what are they trying to do? Authenticate the user. But how does each individual strategy work? Well, GitHub and Google authentication are pretty similar, but something like enterprise single sign-on is very different. But at the end of the day, with OmniAuth, they all implement the same simple interface, which is essentially provide a hook to redirect to the authentication provider, format the authentication provider's data in a specific hash, and redirect the user back to the app. And this strategy pattern provides a nice, simple interface. OmniAuth has hundreds of strategies. And what this tells you, right, is that if you set up your design patterns in the right way, you can solve for a really open-ended problem without the OmniAuth developers needing to know anything about the infinite array of account sign-on services that might exist in the world. Here's sort of a different example of what a template pattern might look like with the report class. In this case, because the implementation is different, but the steps are the same, these two types of reports, the HTML report and the PDF report, they are supposed to implement the same kinds of methods. So in this case, output title and output header, we might have more things. This example is using inheritance, which means that all of the reports, or all of the types of reports need to have the same class methods defined. They need to access the same attributes of the class. Otherwise, they would not necessarily be implementing the same API. But inside a report generation method, what we would do is call out to the particular methods of a particular subclass. You can also do this with composition, but the main thing here is that this set of steps, whatever it might be for your task, are the exact same set of steps. And so here is a sort of modified UML diagram of that as well. But the idea here being that each of our reports has the exact same set of steps. With a strategy pattern, the strategy is a little bit less specific, but what we pass in is essentially some argument, which is either a text definition of the strategy or the actual class itself. In this case, we'd call a formatter. And that formatter provides a relatively simple interface that essentially says, generate the report. Maybe it requires a certain set of data to be passed in, but what it returns back should be consistent, which is, a reference in this case to that report, a file, perhaps a URL to something that can be downloaded. Obviously, that depends on the specific use case, but the strategy pattern gives us a single interface that allows us to at any time add new kinds of strategies to generate these reports. So if we were to call this, essentially we would say every strategy must implement one method output report. As long as that method exists, we generate our report in this case. And again, the central goal for all of these principles is that we prefer composition over inheritance where possible, that composing smaller classes gives us the flexibility to adapt our code in the future. It'll make it easier to refactor. There's a couple other patterns that we can use to address challenges of inheritance with classes and providing additional activities. One of these is a decorator pattern. And the decorator pattern allows us to dry out extensions to classes by essentially wrapping an object in an additional class that provides functionality. In Rails, this is really common to decorate objects that have presentational natures. So in your Rails model, you don't necessarily want to have every single possible way of formatting something like a date or data about your object, but you might decorate a model, which could be your user model, it could be a report model, with some additional methods that help you present that. And the decorator pattern is essentially an additional class that wraps a class that provides a consistent set of methods that allow you to extract some functionality. In Rails, this also comes through with active record scopes. Scopes allow us to share queries without needing to re-implement them on a model. If we wanted to say movie for kids with good reviews, We can chain scopes together. We could have movie with many fans. Scopes and decorators allow us to basically define an interface where we can add methods as we need without having to adapt our entire model. And the nice thing here is that because scopes implement a consistent API, we can chain and combine many small methods without having to implement a unique method for every single combination of queries. Once again, this is composing small classes over inheritance. In practice, with the open and close principle, you can't close against all types of changes. You have to choose at some level what is the interface between a particular class and the rest of the world. That it is impossible to see into the future everything that you might want to do, but our goal is to be strategic in how we choose what types of changes we want to expose. In our agile world, right, the goal is not to build for every possible future operation, but to give ourselves the ability to change when we need. So to think about, in the case of a report, if I don't need 3 different types of report formatters today, don't write 3 different report formatters until you need it, but think about passing in a formatter perhaps as an argument, implementing a small version of the strategy pattern, and then adapting that in the future as you need. The other way to think about this is that you should look for places in which, as you start to modify your code, if it becomes challenging to modify classes, then you take an existing class, extract that code out to provide interfaces where it could be open for extension where it was previously closed. If you start finding yourself writing in particular those case statements and having to adapt them over time, that's a good sign that you might want to create an interface in this class that allows you to adapt it and to extend it in the future. Once you know that, essentially then you close against those types of changes. You can basically say, previously this class required modification. I've now created an opening for a certain type of extension. Once that is in place, you can delete the code, and now the class is closed to modification.